Experiment 2. Determination of viscosity of milk using Ostwald viscometer. Viscosity is an important physical property of food systems. It is related to flow properties of fluids, which in turn control manufacturing operations in many cases. The viscosity of the fluid is measure of the resistance to flow. The rate of flow is decreased by internal frictional forces. Viscosity of milk is mainly due to the milk proteins and the fat present as a colloidal system, and to a minor extent due to the lactose and salts in solution with water. In the case of proteins, in addition to their concentration, the number of their particles, size and degree of hydration also affect the viscosity of milk. In the case of fat, the globular size and the extent of clustering determines their influence on the viscosity of milk. The unit of viscosity is poise, while smaller unit is centipoises. Objective: to learn the usage of viscometer for determining viscosity of milk. To study the various factors influencing the value of viscosity of milk, including compositional and processing factors. To study the viscosity changes of milk with the variation in temperature of milk. Apparatus: Ostwald viscometer with viscosity range from 1 to 3 centipoise. Stands with clamps to fix the viscometer. Thermometer with graduation of 1.0 degrees Celsius. Stopwatch. Pipette 10 or 25 milliliters. Reagents: milk of cow and buffalo, distilled water, sodium hydroxide, chromic acid. Principle: when a liquid flows through a capillary tube, the viscosity of the liquid is directly proportional to the time taken for a certain volume of liquid to flow out under a certain pressure gradient, and also is proportional to the density of the liquid. A comparison of the viscosity of milk is done to that of standard liquid, distilled water, according to the above principle, and absolute viscosity of milk can be obtained knowing the viscosity of water. Procedure: clean the viscometer thoroughly by washing successively with dilute alkali solution, tap water or chromic acid, tap water and distilled water. Fix the clean dry viscometer in a constant temperature 20 degrees Celsius plus minus 0.1 degrees Celsius. Transfer with the pipette a fixed volume of distilled water 10 to 25 milliliters as required, filling about 2/3 of the viscometer bulb, the reservoir bulb. Allow the viscometer with water to stand for 15 minutes. At 20 degrees Celsius, attach rubber tubing to the arm of the viscometer containing the marked bulb and draw distilled water over the upper mark. Close the rubber tube with fingers and release the pressure slowly to allow the water to flow down. Start the stopwatch when the meniscus of water just leaves the upper mark and measure the time for the meniscus to reach the lower marking. Repeat the steps for at least 5 to 7 times and record the times correct up to 0.5 in a tabular form. Take out the viscometer, drain out the water and dry it by drawing dust-free air. Replace the viscometer to the bath and repeat the experiment. Record the times for at least 5 observations in the tabular form. Measure the density of the milk sample relative to the distilled water used in the experiment at 20 degrees Celsius or 30 degrees Celsius as may be the case. Precautions. Only those results obtained from the same viscometer are suitable for comparison. Viscometer should be properly aligned during measurement of viscosity. Observation, calculations, results and conclusions. The relative viscosity of the sample at A degree Celsius. The absolute viscosity of the sample at A degree Celsius.